Working for this startup in Mountain View called Rapport. We do financial software. We have an interactive investment analysis and reporting technology that is future-proof. Essentially, it's a tool that helps wealth managers manage people like Mark Zuckerberg, Sheryl Sandberg, and other billionaires that I will never be. I'm also a former co-host of the InfoSec Daily podcast. Hopefully some of you have listened to the podcast before. If you haven't, we did a lot of episodes every day of the week before we stopped. I started off in the information technology field as a developer writing really bad code. Eventually, somebody discovered that I don't have the talent to be a good developer and decided that I should learn some security. I started doing code reviews, and then I eventually figured, hey, I'm good at this stuff, so let me just be an application security engineer. So what I do now is I break things, find problems, and recently I have started fixing them. So what am I talking about? As I said, the title makes very little sense. The talk is about how you can actively participate in improving your apps, improving your application security program. Hopefully the font there isn't too small. Well, it's not. Cool. Every one of us performs an active or passive scan, finds problems, files bugs, things like that. We might even have interactive touch points, have weekly touch points with the development teams, product teams, whatever, tell them what to fix, tell them what is important to us. But there's a lot more we can do. I'm going to talk about that soon. It's also going to be about how you can make the product team come to you versus it always being a catch-up with the product team. There's been plenty of times when we've been blindsided with some feature that we thought wasn't on production, but hey, guess what? It's on production and you didn't even know about it. How to reduce the burden on your DevOps team. Now, DevOps is a newish concept. A lot of you might not even have DevOps in your company, but in a startup, DevOps is this big new thing. These are the guys that manage they're sysadmins, but they also handle the development side of things. So they own certain things, like logging, access control, and I'm going to talk about how you can make their lives easier by taking over some of this, or at least by helping with some of this. It's mostly about what I've learned in the last 10 months as a security engineer at a startup. A lot of you might know what I'm speaking of, and it might be obvious to you, but a lot of this wasn't obvious to me and to a lot of people I spoke to. So I said testing and finding bugs isn't enough, but it's definitely a good thing. It is very, very important that you actually test and file bugs. You need to have in a good application security environment. It's critical. If you don't test, if you don't know what's wrong with your environment, you can't fix it. Again, there's a few things that are very obvious, like ensuring that all your security bugs are in a ticketing system that you're tracking, ensuring that there's a separate category for security bugs, and that you measure everything. It's important to know, look at this graph and figure out, hey, there's these many bugs filed, and we've been fixing it at this rate, and there's these that have been open for a very long time, so that 1 year down the line, every year, when you're looking at your roadmap, when you're trying to figure out what you want to do, how you want to do it, you can say, why did these things not get fixed? How can we do it better? And what can we do to make our environment better? But an obvious thing is that filed bugs is not the same as fixed bugs. Right? Product teams don't necessarily care about non-critical bugs. If there is a bug that they know isn't going to cost them money, or that isn't easy for an attacker to get to, for example, if you have a feature behind an authenticated form that is available only to a certain set of people, they're going to say, oh, the risk is very low, we're not going to do it, but even though you might want them to fix it. As a result, you might end up with bugs sitting in the system for multiple months, or in unfortunate cases, multiple years. So, there's a way to fix this. It's not easy. It's not straightforward half the time, but it's possible. You can start by fixing your own minor bugs. If you, like me, haven't ever coded in a formal development environment, this can be hard. It's not as easy as, hey, let's make this hack and fix everything, because people are not going to like it. Your fixes need to be production ready, and they need to be non-hacky. It needs to work not just today, but it needs to work 6 months down the line, 1 year down the line, and it needs to be peer-reviewed and all that. You'll definitely need the development team's help to do this. So when you say fix minor bugs, what am I talking about? So when I joined the company, there were some minor bugs, like there were sensitive data in log files that didn't really belong to the customers, but belong to developers. But still, you don't want stuff like names and passwords and logs. We had a system that was collecting certain data that we didn't want, so you can remove that. It's straightforward. You can just add things like HTTP headers, simple ones like XSS protections, X-frame options, content sniffing, HTTP strict transport security, a whole bunch of these things. And all of these are easy, no matter what framework you're using, be it Django or Java or .NET or whatever. Adding a HTTP header is really straightforward. And it's a good way to learn how things work, and especially if you have a custom web server, not a custom, but if you have like a Jetty that you've configured for your REST API or whatever, it's important to understand how they work. Okay, so let's step back a little bit. A lot of security engineers that I've met, unfortunately, have the opinion that developers aren't smart people. This is patently untrue. If you have a successful product and a service, odds are your developers are really smart. There was a black hat webcast I attended a few months ago where one of the speakers made a reference to developers and pets. He said, developers are similar to pets in the sense that if they do a good thing, they need to be rewarded so that they keep doing the same good thing. That's a bad way to put things. Humans like to be rewarded, be it a developer, be it a security engineer, they just like to be rewarded. Having a derogatory opinion of them is going to be bad for you, bad for their morale, and it can be really toxic. It hurts you. At the end of the day, if they have a bad opinion about you, they're not going to help you. They're not going to help you fix things. They're not going to help you do things. It's going to be bad. So, in order to fix bugs, you need to identify security-savvy developers. Now, these aren't that many. There are not that many developers that understand security very well. But there are a few. There are those that at least care about security, that want to understand better, and have worked on some security critical features invariably, like the authentication system, the permission system, whatever it might be. So, as I said, the security savvy is the critical part. They also need to have been in the company for a little bit, or need to understand the code base really well. If you pick somebody who's as new as you and they don't understand the code base really well, the odds of you learning a lot from them is very small. They need to be able to point you to the right places, tell you what to work on, and tell you, at least at a high level, how a certain thing should get done. The most important part, though, they need to be interested in working with you. There are some really smart developers out there who are also security conscious, who know a lot about security, but they don't necessarily work well in teams. They don't necessarily work well with other people. If you pick one of these guys, you're just going to end up getting stonewalled. And you're going to be like, that image is too small, but you're going to be like Simpson there, between a rock and a hard place, swinging, and you're not going to know what to do. There's a few good ways to reward developers for being security conscious. Bug bounty is all the rage these days. There's a whole bunch of companies that are doing external bug bounties, but internal bug bounties are also important. At Rapport, we actually like to reward people that find security bugs that weren't obvious to us, or that they found because they know a particular feature way better than we do. So, it can be something as simple as giving them a special edition t-shirt. It can be something as simple as giving them a lockpick or a hat or anything like that, but appreciating them for going out of their way to find a bug or file a bug is a good way to appreciate what they did for you and encourage them to do more for you. So, develop trust and rapport with these developers. This is important. You need to take the feedback that you get seriously. Initially, odds are when you write code for a company that you've just started with, you don't know the way they work, you don't know the styles, you don't know the, the coding mechanism, whatever it might be, and you're going to make mistakes. So when you make mistakes, you're going to get feedback, and you need to take it seriously so that you don't repeat these mistakes. Tackle bigger problems. There's plenty of big problems out there, especially for a small company. These are not mission critical. These are not things that are priority for development teams, but there might be priority for you. Things like logs. You're going to have logs, right? You're going to have web server logs. You're going to have default logs, but application logs like that give you specific information is not necessarily something that you're always going to have. You might have something that give you information about the performance of application, but about the security of application, probably not. Like, when a bunch of login failures happen, you need to know what firm they happened in, what credential they happened under, stuff like that. And implementing this isn't really hard. You can also do things like adding role-based authentication or something to API calls. For example, we have a bunch of roles in our system, and one of my first projects was to make sure that only the right people made the API calls to the right things. You could also improve existing code, even non-security code. Like if you can find a way to refactor something to make it cleaner, you should probably do it. But you should probably focus on things like credential and password mechanisms so that you add better code, make it more readable, stuff like that. Again, write good code. I cannot emphasize this enough. Bad code is bad for you, bad for the company, and it's going to make people hate you 6 months down the line. It's going to happen. I've written bad code, I've seen bad code, and I've cursed them plenty of times. More importantly, don't break shit. It's easy to do this, especially if you don't understand the environment. It's easy to break builds, it's easy to break unit tests, and easy to disable unit tests because you don't understand them. It's also easy to introduce a regression. A feature that was working perfectly might not work anymore because of a refactor, or because of a security feature you added, or whatever. These things happen, they're inevitable. Everybody does this, but the goal is to not do this as often, and if you do it, fix it immediately. So when you go through, when you work with developers, when you go through these code reviews, sometimes they fix the bad code you wrote. One of the first projects I worked on was adding application-specific logs. I wrote some shitty code. I did not follow our company styles. And this guy went ahead and fixed it for me and said, hey, here's the things I fixed. Can you take a look at it? I looked at it, learned from it, said, okay, cool, thanks for doing this. Other times when you've been there for a while, they just ask you to get your shit together. This was pretty recently, actually. 2 in the morning, I find a bug. I thought I fixed it. I thought I came up with a really smart way to do it. And in the morning, I expect it to go through, get it merged immediately. This senior developer is like, yeah, this is shit, this isn't going to work. And then I make another fix, it's like, this is really bad, you should probably come up with a better way to do this. And I did. Eventually we got it worked out, we came up with a good way, but, it's important that you don't take this feedback the bad way, you don't take it personally, you don't take it like, oh, this is bullshit, I don't want to do this anymore. And it's easy to do that, especially when you're not as experienced at coding as some of these guys. It's easy to be defensive about what you do. At the end of the day, it's practice that makes perfect. Get involved and take ownership of important things. And this can be a lot of things. At least in a small company where the product is continually evolving, there's always going to be major features added. There's going to be major pieces that affect the security of the product. Take ownership of some of these. For example, in my company, we had a migration from using Node.js as a proxy to a REST API to just using CORS. CORS, for those of you that might not know, is cross-origin resource sharing. This is something that's incredibly security-oriented that you need to know that the developers can use your help with. So when something like this comes up, it's important that you step up and say, hey, I can work with you on this, or I can take up this piece. And when you're doing this, you can test and develop at the same time. It's pretty easy. It's not overly hard. You already know some of this stuff, and odds are they've already written the backend code that help you make it easy. Another good project, especially if you take in user supplied HTML is introducing a sanitization library. Anti-SAMI is an OWASP library that, I forget who wrote it, but it's a really good library to do this. It's a great way to sanitize HTML and understand how things work and introduce it. So yeah, we have an anti-SAMI service implementation that whenever user-supplied HTML comes through, it goes through it, sanitizes it, and makes sure it stores only safe HTML. It's released as a BHD, it's an OWASP project, and again, it's super useful when you have user-supplied HTML, or even CSS for that matter. It comes with a default set of rules. It's got, eBay uses this because there is an eBay rule set which is pretty good. And it's also got simpler rules for if you want to load richer content. See your work through. This is important. It's important that when you start something, you finish it. When you start something, that you get it to production, make sure that it's passing unit tests, integration tests, QA, and if there any functionality that you broke because you added a feature, for example, you added anti-SAMI, and that broke a bunch of formatting, it's important that you fix it. It's important that you volunteer to fix a particular bug and say, hey, I know I introduced this bug, let me see if I can work with you guys to fix it. It's not necessary that you work alone. Again, it's important that you volunteer your help to the people working on it, or say, you know, I know what I did, maybe I can do this myself. So I'm saying a lot of things. Why is this important? Why do you need to do this? It's a lot of work. This takes a lot of time to do. It's important because this makes you part of the process. You're not a blocker anymore. You're not just filing bugs and making people do things. You're actively participating in the process. You're making an impact. Developers start treating you as part of the solution. They don't treat you as part of the problem. So when they have a security-related question, instead of shying away from asking you because you might say things that make their work harder, they will respect your opinion. You understand the code base better. In my company, we see almost 40 to 50 pull requests a day, or at least 20 to 30 new features a day. It's important that you know what is happening. If you're oblivious to the new features getting added, or if you don't really know what is happening, then you lose track of it really fast. You lose track of the security critical features of it, security critical parts of it really fast. So it's important that you understand the code base better. The product teams come to you when they're coming up with a new project. Instead of being that, oh shit, we got to talk to that security guy, you're like, oh hey, let's talk to the security guy. And that makes a huge difference. You get street cred. Again, if you respect developers and work with them, they're willing to work with you, and they tend to listen to your perspective. So I've been talking nonstop. I need to drink some water, so here's a cat riding a skateboard. For those of you that don't know, this is an awesome cat. His name is Didja, and he actually rides a skateboard. And he does backflips and bungee jumping and all kinds of cool things. It's pretty awesome. So yeah, I said all these things. All of these were highly code-oriented. All of these involved a lot of work that wasn't necessarily security-related. What if you don't want to write production code? Or what if you hate Java? Or what if you hate Python? Or whatever language is in your environment? That's fine. There's a lot of other great things you can do. For example, code review. It's not overrated. Code review is important, right? It's very important in an agile environment. Agile is no longer that buzzword anymore. Agile is real. Almost every one of us is in an environment where there's rapid deployment, rapid coding, rapid iterations. So you can also work with your DevOps team, your sysadmins, your infrastructure team, whatever you call them, on some infrastructure-related things. Let's start with code review. Go to fail. That could have been prevented so easily. But as I said, code review is important. Reviewing code before it hits upstream is critical. We call it master, it depends on whatever source code system you use. But it's pretty hard, at least in my company, for us to review 60 plus commits a day, and that's on a slow day. So, when there's a continuous influx of things coming through, it's easy to lose track of, hey, what's happening? I can't do this anymore, or I don't know if this is security critical. Should I do this? Should I not do this? There's tools that can help with this that cost a lot of money. But there's also tools that are free, and that's what I'm going to talk about now. RepoGuard is a tool that the awesome security people of Prezi wrote. For those of you that don't know Prezi, it's a great presentation. It's online presentation software or service that helps you make your presentations much more interactive and better. I couldn't use it because I was lazy. But RepoGuard is a great tool. They wrote it with a bunch of rules that look for interesting changes. What it does is it hooks up to your GitHub repositories, your organization's GitHub repositories, and based on these rules, it pulls down all the commits, or at least the last 100 commits for each repository, and looks for changes like this. You know, if you're using jQuery, it says, hey, are you using .html or .inner HTML, because those are dangerous functions. The good thing about this is that if you don't use JavaScript or jQuery, that's okay, because rule sets are extensible. We use Handlebars in our company. It's a templating engine for JavaScript. And in Handlebars, triple braces are a bad thing. That's the same thing as saying, I'm going to put the user input exactly the way it came to me, which is obviously bad, right? So adding a rule for that is as simple as saying match this particular, I don't know what happened, but yeah, match that particular line there. It's pretty awesome. Running RepoGuard, also pretty fast. All the requirements are cleanly laid out. The documentation is really good. You just have to give it the, add the configuration file for it, give it the required things, and you can just run it. -- notify sends you emails, refresh fetches new repositories, limits to the repositories that you care about, and stores it in Elasticsearch. The Elasticsearch part, at least for the context of what we're speaking about, is pretty important, but we're going to speak about that in a little bit. But yeah, you give it the right options, you added the right configurations, you let it rip, it's going to do its job. It's going to go through all the commits, and it's going to send you the alerts. The alerts are sent via email, at least they were until recently, and they look somewhat like this. As you can see, it's not necessarily easy to parse, and as I said, when you have 60 plus commits a day, and you're getting 20, 30 alerts a day, it can get very stressful and your eyes will glaze over it and you might miss important things. It can, as I said, it's very hard to parse. When I got these emails initially, I was like, yeah, I don't know what to do with this, I can't track this, and multiple people receive these emails. They're like, yeah, I don't know what you're looking at, I don't know what I'm looking at, and so we just found it a little hard. Which is why, just for DerbyCon demo, we wrote this. We wrote a UI for people to parse these alerts. So I worked on this specifically for DerbyCon release. The backend for this is written in Flask, and it's very extensible. For those of you that don't know Flask, it's a pretty awesome web server in Python, also a web server framework in Python. The front end is Bootstrap and jQuery. So for those of you that can do better styling than me, you can extend it however you want. jQuery is also pretty good for easily modifying and adding new features and stuff like that. So this reads the results that are stored in Elasticsearch, displays them in an easy way, and you can track the results. The current features include, marking as false positive, filtering by repositories, filtering by rules, and filtering by reviewer. So without further ado, let's see if I can demo this to you. I should probably mirror my screen. Good. So for this demo, I just decided to use OWASP webcode because, let me know if that becomes too small. Probably shouldn't, but I decided to use OWASP webcode because I don't want to show results from our repositories for obvious reasons. So I just give it the organization, which is WASP, and ask it to pull down all the commits, and it did. And it pulled down a whole bunch, it shows a whole bunch of alerts here. A lot of these are going to be false positives. That's just the property of a source code scanner. It's a regular expression matcher. It's going to look for certain things, and if it sees it, it's going to alert you on it. You can obviously improve the rules, remove the rules. For example, this has been triggered because of this particular string. It's HTTP versus HTTPS. So it says it's an insecure protocol. That's okay. You can always mark it as a false positive. That just involves clicking this button, and that's gone. A lot of these are going to be false positives until you refine the rules for your organization and make it better. But with this interface, it's just easy to make them go away by just clicking on that button. If you don't want to look at only specific issues, you could do that. You want to look at all the XSS issues, for example. You just do that, and it shows you all the different XSS issues here. And most of these are going to be valid, right? So, for example, this is very much valid. If you want to look at the context of it, you could just click the file, and at some point today, yeah, cool. So you can read the affected code right here. You don't have to go to GitHub, go to that particular commit, open that particular file. You don't have to go through all that effort. You can just look at it right here, which I found incredibly useful when I was going through the alerts. So you also, all the results are paginated. At this point, I was lazy to give you a pagination function, but option to have more page results in a single page, but you can click on older, newer, whatever. You can also change the dates. Elasticsearch keeps track of when the results came in. So if you want results from last week versus this week, you could do it. If you want to filter by reviewer, like if you want to see all the things that certain people in your team did, then you could do that too. So, right now there's only one reviewer because I haven't really reviewed any of this. But yeah, that's ReproGuard. You go, oh, the other thing, you could also look at false positives. Anything that didn't work. That's weird. Okay, so you could also look at false positives. Anything that I just marked this as false positives, and it shows up here. And if you don't think it's a false positive, you can always remove it and mark it as valid again. So that's ReproGuard. That's the tool that I'm releasing today. It's available already. I'm going to go back to my slides in a little bit so that I can show you where you can get it. So yes, ReproGuard is available open source. You can download it from github.com/prezi/ReproGuard. I'm hoping to make these slides available online, so the links will be there as well. So that's about reviewing comments, that's about writing code. But there's a lot more you can do. So our company has the concept of DevOps. We have these sysadmin/DevOps/ these people that manage our infrastructure, act as DBAs, deploy code, all these different things. They're awesome. They're really good at their jobs. But especially in a startup, they're always incredibly busy. And they have a ton of things to do. So you asking them to do things that aren't necessarily priority for them is just going to piss them off. So what you could do is you could make their lives easier, and there's a lot of ways to do this. Logs, for example. Logs are your friend. Again, this is traditionally something that a DevOps or a sysadmin does, but security guys like logs too. This is how you find out if somebody broke in. This is how you find out if there's a botnet trying to scan you to exploit shell shock. That's a terrible name, but the bash bug. They're all aggregated into it's in your interest to make sure they're all aggregated into a single place. So it's good to have a centralized logging mechanism. There's a lot of ways to do this. You could have a commercial solution, for example, Splunk, pay a lot of money and do that. Or you could use things like rsyslog and syslog-ng. You could use Gelf plugins for, Gelf is a Graylog extended log format. I'll talk about it a little bit, but to get application logs in. Back up your logs, this is obvious. Use the same time zone for all servers. This is harder than it seems. A lot of times, initially when I started looking at logs, some of them were in Eastern time, some of them were in Pacific time, some of them were UTC. I was constantly confused. Eventually, NTP solved the problem for us, but it's harder than, it's not something obvious a lot of people have. So, one easy way to access your logs and get them in a single place is obviously RSS log, but also having something like the trio of Logstash, Elasticsearch, and Kibana. This is, again, open source. They collect, parse, index, and search logs. So, I spoke about Gelf, the Graylog extended log format, which helps you take application logs and send them straight to Elasticsearch via Logstash, which is pretty awesome. It's indexed in Redis, and then Kibana, which is an awesome interface, helps you search Elasticsearch and gives you a nice looking dashboard that you can share with people. It presents in an easily consumable way. So when you want to build a useful dashboard, for example, your security monitoring efforts, you want to see all the LDAP fails, you want to see any attempts at exploiting a bug, you want to see some things like that, it's easy to do so. So you can use this for your daily, weekly, whatever monitoring that you do. You could even have it on like a big computer screen that gives you a 10,000-foot view of what is happening. So it can be incredibly useful. The other thing you could do is access control. There are companies out there that have the philosophy of freedom and responsibility that give developers and engineers access to every single server. This, to me, is scary. I don't know why people do it, but, you know, if they're accepting that it's a good thing to do, that's fine by me. But you probably don't want to do that. You want to have some sort of access control. This takes a chunk of a sysadmin's time. You know, you might have various ways of requesting for access. It might be filing a Jira ticket. It might be filing some other request. It can be a whole bunch of things. But access control is one of those things that takes a DevOps or sysadmin's time. So automate it. At Rapport, we use a tool called Doorman. It's an automated system. Essentially, you request access to a bunch of servers that we have. You tell us how long you want access for. The maximum below right now is 10 days. You give us your SSH key. Most of our servers are Linux, and you access them via SSH. And you give us a reason. When you click on submit, it goes to your manager. Once your manager approves it, if we deem it to be a critical server, and that's also programmatic, it asks for a second level approval from either the security team or the DevOps team. And when they say, yeah, it's good to go, it talks to Jenkins, which is another awesome tool, and says, create this user for me on the server. Jenkins automatically creates the user, marks it as done, and sends a response. And our tool says, okay, you're good to go. Every day, a script runs that removes users from whatever servers they shouldn't have access to, and they automatically get removed. It's awesome. You're cutting down at least 2 hours every day of the sysadmin's time, if not more. And they will love you for it. They will be happy to do something else that you ask them to do, because now they have more time to do it. I wish I could open source this, because this is an awesome solution, but we can't because it's too tied into our internal libraries. Perhaps at some point in the near future, we're going to do it. A lot of things I mentioned so far is coding and more coding and more coding, and that's because I'm kind of oriented that way. But it's not all about coding, though. There's a lot of things that you can do that don't involve a lot of technical things. For example, developing security training for developers. And that's a weird statement to make, but yeah, create security training for developers and make it fun. Nobody wants to sit through yet another class talking about how to parameterize SQL queries. One way to make it fun is to come up with a company-specific CTF. Use the vulnerabilities that you found in the last, like the recent ones that were critical, and modify them a little bit, make them a CTF challenge. That way, developers understand your process, how you look for things, what you look for, and it makes them understand how to do things better. Another thing you could do, if you don't have an incident escalation and management policy, probably something you could write, because that also is cross-platform, involves multiple people. And small startups, at least in companies like mine, it's important to wear multiple hats. So, it's important that you do this. So, participate in cross-functional projects that impact what you do as a security guy. But you shouldn't do all the things. You're not Chuck Norris. You're not going to be able to do all the things. I've been saying, do this, do that, do this, do that the last 30 minutes. So you must be really confused now that I'm saying don't do everything. There's a difference between being involved in everything and doing everything. Your job at the end of the day is to identify potential security problems and to make sure the product is secure. Don't try to be a developer. Don't try to be a DevOps. Be involved in what they do, be aware of what is happening, and be prepared to participate in it if it need be, but it doesn't mean that you have to do everything that they do. For example, if there's a critical security bug that comes up, you know how to fix it. You have to make sure that it gets fixed, and if there's nobody else available that's more qualified to do it, you could probably fix it yourself. But ideally, you're the one that finds it, and then, helps people fix it. But it's important that you don't try to do everything. If there's a project that impacts security, like there's a new permission system, you shouldn't be the one writing it. You should be the one testing it. There are certain things that you should do. There are certain things that you should be involved in. Make sure you draw the line. Make sure you're aware of what this is. This is important, and this is hard. A lot of times my manager has to tell me, this isn't our job, you shouldn't be doing this, and I have to argue with him because I really want to do it. But you have to recognize when to stop. So, concluding, the whole point of this presentation is you should be part of the solution. You should not be part of the problem. You should not be a blocker, someone who tells people what to do. You should be involved in it. You should know what you're talking about, and you should get people to respect you. That involves respecting people, respecting developers. They might not be great security guys, but they're extremely smart coders, and respect them for it. Perhaps they will respect you back for what you do, which is break things. Participate in things, teach things, learn from others. Evangelize security, make it fun. That small image you see there. So in our company, a lot of people were leaving their computers unlocked, and we had these small sheets of paper that told them, hey, lock your computer. It wasn't super effective. So I came up with this website during a hackathon, spent some 30 minutes on it. Whenever they leave their computers unlocked, we go to a website, it's ihasroot/their username, and it counts the number of times they've left their computers unlocked and results in a hall of shame. So, if they leave their computers unlocked too many times, they're going to show up at the top of the hall of shame. They don't want this. So, they try to leave their computers locked. In fact, there have been times when I've walked out of my desk and people have run back to lock their computers. That's a good way to teach people things. One last obligatory slide. We are hiring. We're not hiring for security engineers, unfortunately, but there's a lot of other positions we are hiring for. Go to rapport.com/careers to see if there's a bunch of software engineers, sales engineer positions. So if you know anybody interested, if you're interested, please go there. If you have any questions, if you want to curse me, if you want to criticize me, you can do it right now. We have about 7 minutes or so. You can reach me via Twitter or via email. So that's my presentation. Thank you for listening, everyone.